So before we go into into the actual shaping of our sim, or really like the disturbance and detail, the cool thing about sparse is that it will, keep expanding the domain as it goes. It doesn't start with a big domain, meaning, the world that's simulated, but it'll also just keep expanding forever if you let it. And right now, our sim is going further and further and further. And that's fine probably right now because our resolution is still quite low. We never changed it from the default of the 0.1. But I want to give it some limits now. It needs some boundaries, like a child. So, just press escape. I don't need it to sim right now. So, well, actually, maybe I do want to see it. Let's make a box. It's just a random box. And I want to figure out, I want it to be roughly like this, probably. We want to make sure we have some padding. I don't want to be too aggressive with this. It should obviously go to the top, and then it'll need to come out, I guess, but that's harder to figure. So something like that. Ta-da. So what does this end up being? This is going to be the basis for this. Back on the smoke object, we have this center and max size thing that we can turn on. Oops. Oh well. Oh, it's back. Let us round these numbers out as usual. I'll just say this is 0. This is 0. Now really the center here should just be however tall it is times 0.5 so that it's resting on the ground. Except I don't want it to just rest on the ground. I want to make sure that it gets down to where our close below thing is. So I'm going to copy parameter on the voxel size here and subtract that out from this just to move it down just a little bit. Good. So now it's there. So we have these dimensions. We came up with them visually using a box. I mean, we could have literally just typed them in here, but I like to make a visual box and then just bind the expressions back to over here. So again, copy, and make sure you do this right because they're switched. Center here is after size, and here center is before size. So just be careful that you're doing that right. So what does this do? Well, pretty much like I just said, this is the maximum bounds, although it's not quite right. It is the maximum bounds, but I guess I should just have density or something on by default while I'm in here. So this is the maximum bounds, even though this is the actual, thing that's being stored in memory. But for the record, while this is respected completely, treat y as closed below this exact value, negative 0.1, this is not actually completely respected because when it sims, it can only increase the simulation by these full tiles. Or at least you want to do that. It's more efficient that way. And that's what the defaults are on the solver. We're not even really going to get into that too much. Just to say that if your max size does not literally match up to a full tile, like let's say the full tile would have bled out a little bit, it'll still put the tile there. And so your max size will end up being like a little bit bigger. We can prove that actually pretty easily if we turn off the treat y. Now, technically speaking, this should just be resting on the ground. But if we look at it, you can see it actually goes below the ground quite a bit. Even though, a thing centered here with this size should pretty much just be one voxel below the ground. And you can see if I did turn this back on, close below, it would be that. So it will go a little bit further. So just be aware that this is not exact, but it's within one tile's worth. So just so you know. Make sure this is still on, and there you go. Let's cache some of this stuff though. We've been doing a lot of this in memory over and over again, but we're gonna want to have to start to cache this stuff now. Go to File, Cache. Put it here. And we'll say, let's use that data variable. Remember we made that before? So data /sim/ I don't know, sim, maybe? frame.bg.sc. You could put like, you know, /version0 or something in here too, but most of our version stuff we're gonna do later in this lesson is gonna be with wedges. So we got that. We want to load it from disk. Once we have those files, you know, it errors now because those files don't exist, but otherwise everything else is pretty much right. Save frame range. If we were to save some of the easy frames here in the beginning, very good, whatever, don't care. There you go, and then errors after that. What can be nice here is to take this pyro post process and put it after here. Because I can't, once I save these files to disk and I'm reading them from disk, I can't change anything up here anymore because I'm just reading a file. So it's good to have one down here too. I can do further changes if I so desired. What could be interesting to see though is Pyro post process doesn't just do visual stuff. Pyro post process also does post-processing stuff in the form of compression. So let's go find some of these files that I just made. There's the sim folder. There they are. So let's deal with frame 20. So here I am on frame 20. I'm going to go to save current frame. In fact, I'm just going to delete everything that's in here to make this a little bit more clear. So save the disk. And now I have that file. Now this file, by default, is 4.8 megabytes. And that's because it's storing temperature, flame, and density. But I might need velocity also. We have velocity in our sim, and I might need it for motion blur. So let's go to DOP import fields, click plus, and put vel here. Now looking at it, it looks insane. I mean, you can hide it, but even this looks weird. It doesn't look cool until we get to the post process anyway. Oh, and by the way, turn off assign render material. We're going to make our own material, of course, later, and it's going to be really cool. But we definitely don't want to use this one. So turn that off. Keep apply look on, because that's what's doing this. But turn that off. But at any rate, so now we have the 3 velocity fields, one for X, Y, and Z. Let's save that, and you're going to see that disk space jump up quite a bit. 26 megabytes now. Yikes. So currently, even in our low res sim, this is pretty low res. I mean, just look at the middle click here. 200 by 100 by 200. I mean, that's nothing. We could go way higher than that. So we're going to want to be able to save these things on our disk, especially once we start wedging. We have multiple simulations of cache files. It's going to take up a lot of disk space. So we really need to manage our files, our outputs, and make sure that they're as small as possible. But again, the Pyro post process will do that for us, or will help us quite a bit. We discussed some strategies in volumes 4 on how to do it, and here's perhaps an even easier way. First of all, convert to VDB. That alone won't really do that much. What it will do is it will merge our 3 velocity fields into one, which is convenient more than anything else. But there you go, save the disk, look at it. So we went from 26 megabytes to 25 megabytes. I mean, you know, not that cool. But resample volumes. Velocity being its full resolution is super important while you're simming. You want all the little details of things moving this way and that. But by the time you get to motion blur, it doesn't really matter that much. Certainly we could say down res it by a factor of 2. That only means that we're kind of blurring the velocity between 2 very small, voxels next to each other. You're definitely not going to notice that, especially with camera blur, and I mean, you're just going to notice either way. But this will be massive savings right off the bat for almost no loss in visual quality. So save that to disk. We've cratered to 6 megabytes. We were just at 25. So we just saved a factor of 4, pretty much. So that's sweet. What else can we do on here? We've got U16-bit float. Floats, as you may or may not know, is how we store numbers, and we use bits, of course, when you talk about data and such. and how many bits you use. The more bits you have, the more resolution, or as they call precision, in the number. So long story short, by default we use 32 bits, 32-bit floats, as you can see in the little description here. So this will mean that the precision will be half as much, but it also means that the amount of data you need to store it will be half as much. Half. So save that. We're down to 3.4 megs now. So we went from 26 megs to 3. I mean, that's like an 8 times, almost 9 times savings. It's pretty huge, especially once we get to resolutions that are 8 times larger than where we are right now. Or 8 times as many voxels, I should say. Yeah, so what does that loss in precision really mean? It means that if a voxel has a density of 2.14359, it will instead be saved as 2.143. I mean, this is as an example. You're still going to have a pretty precise number. It's just technically not going to be as crazy precise as it was. So really nothing that you need to lose sleep over. And that should do it. For this, we don't need to post-process. We don't need to do it again after we save it. So we just need to have that done here. In fact, we don't want it to do it here because we don't want it to do the voxel scale 2 times. And we just don't want to waste our time with any of the conversion stuff. So just keep everything off for this second one. And we can save this whole thing to disk if we want, but no real point because we're about to make this look 100 times better.